Now let's look at what lists are in Prolog. So basically, in a way, you can say that list is like we see lists in Python as well. You can treat them as arrays, if you will. So you are allowed to add lists in Prolog as well. Basically, list is an ordered collection of terms. It is denoted by your square brackets, for example, 1, 2, 3, or red, green, blue, like so. An element can be any type of Prolog object. Different types can be mixed within one list. List used in Prolog, where arrays may be used in procedural languages. So basically, it is the Prolog's alternate to an array. And not any non-empty list. Now, this is very important. All non-empty lists are basically thought to be of two parts. There's the head and then there's the tail. So the first element from the starting from the left is always the head, and everything else, no matter how many elements there are, everything else on the right side will compose it as the tail. So let's just say it can be written in this way, that I can treat an array or a list in this way, that the first part is the head and this separator, the rest part is the tail. So for example, if I have this array or this list, car, lorry, boat, or ship, the head part, the H part, will have only car in it, and the tail part will have lorry, boat, and ship. So what this is stating here is that in terms of head and tail, the head will always be a single element. The head will always remain a single element. Single element. A head will always remain a single element. Whereas the tail will always remain a list. Even if there is no other item in the list, the tail will still be considered as an empty list. But the tail will always remain a list, always remain a list. So the head is just a single element and the tail is always a list. So let's just say I have this list here, 1, 2, 3. So I'm going to call this my list, and my list has the elements 1, 2, 3. Now, how do I read this? This list 1, 2, 3 is my list. You see, this entire list is a parameter for the fact my list, for the predicate my list. So the list 1, 2, 3 is my list. That's a fact. Now, I am attempting to separate my list by the format of H separator T, using this format over here. So my prolog automatically does what? It instantiates H with the first element here and T with everything that follows the first element, excluding the head. As you can see here, tail is mentioned as a list, as it can be seen with the squared brackets. It always will be a list, always. But the head is only a single element. The tail is always a list. Now, a rule states there's a loose rule for empty list. Now, A is an empty list if A has no elements. So I just defined a rule here, and the rule states that A is an empty list if A is equal to empty. There's no elements in this list. Now I am checking if is one and a list with the value 1 in it, is it an empty list? It runs false, because the rule states that A, let's say it instantiates this list with A. Does A have nothing in it? No, A has 1 in it. That's why it returns false. Now, similarly, if you can see here, a built-in predicate append A, B, and C, this should be capital C, joins the list A and C and list B and produces a list C. So how do I read this? That this is a built-in predicate, by the way. So basically what it does, that I have two lists here, A and B, and once I combine these, what it does is that it combines these two lists A and B together and simply concatenates them and stores the result of the combined list in the variable C and creates a new list. So that's what this predicate does. Now, for example, if I'm using append here, there's this one list here, A, B, that's my first parameter, is a complete list, A and B. My second parameter is also a complete list, C, D. And when I run this into append predicate, sorry, append built-in predicate, what it does is that it combines A, B, C, D, and stores the result in my list. So that's why after this fact is run, my list will have the values A, B, and C, D as proposed by this built-in predicate. Similarly, if say my append predicate is run this way, and as you can see here, this is a variable. I don't know what this is. And same thing, this was also a variable. Now this is a variable. Something when appended to this list produces this complete list. Now, obviously, I know the complete list and I know the second part of this list, but I don't know the first part. So this first part is naturally associated with A comma B over here, because that's what the rule states. With the finalized list, the second part will be here, and the first part will definitely be something over here. So if my finalized list has CD as the second part, then the first part must definitely be AB, and that's why you instantiate first list with A comma B over here. Now, let's see what's happening here. There's another built-in predicate which is known as member. So it basically determines if this atom or this parameter is a member of this list over here. So is C a member of A, B, C, D, E? Yes, it returns true, because yes, C is a member of A, B, C, D. Similarly, by the way, this is another built-in predicate. Similarly, if I'm asking X, this is a variable. So basically, who is a member of A, B, C, D? So it returns A can be equal to B, X can be equal to A, X can be equal to B, X can be equal to C, and X be equal to B, because all of these values for X satisfy the rule that it is a member of A, B, C, D. List processing predicates for writing and reading data. The built-in predicate write something here outputs the value A to the screen. So for example, if I want, this is the equivalent of your, prompt in that we use in high level languages. So I write something in double quote will print this word as it is on the screen. Similarly, write X, as you can see that this is a variable, it will output the contents of X that are currently stored in X on the screen. So this is again how I'm using Prolog in a way like we do in any high level language for printing something on screen. Similarly, I'm also allowed to read something from the keyboard. So for example, the read predicate or read factors that, so whatever I input for the keyboard will be instantiated with the variable A. So read A means that whatever I input at that particular moment will be given to the variable A. So for example, read name, as you can see, name is a variable. So if I input a value at that time, that value will be stored in name. Note that the input must start with a lowercase because I'm treating it as an atom. If I give it an uppercase, it will be treated as a variable, and I don't want that. And if it must not have spaces or enclosed in quotes, because that is to be treated as an atom as it is. And all atoms are lowercases. Okay, if I use N1 outputs a new outputs the values into a new line, kind of like how we do in high level languages as well. So we can use \n to print something on a new line. We can write user-friendly programs using the read and write predicates. So if you want to take an input from the user or present result with the proper prompts, we can use the read and write predicates as mentioned here. So this is the basic use of Prolog. And in the subsequent lectures, we'll be trying to discuss more examples regarding to Prolog as well. But in the meantime, this is the basic working of Prolog.